Today we're going to be doing valid palindrome. So let's have a look. Given a string s, return true if it's a palindrome, otherwise return false. Oh, that's easy. So what is a palindrome? A palindrome is a string that reads the same forward and backward. So if you have race car, it's R-A-C-E-C-A-R, and then you read it backwards, it's also R-A-C-E-C-A-R. It's a palindrome. So your input is a single string, yeah? Also a little tidbit here is that it's case insensitive. So if this is race car with a capital R, this is still okay. And it ignores all non-alphanumeric characters. So if it's race, space car, like this, space car, we still read it as R, A, C, and we don't treat this as a space, we ignore this, and then E. So then this is just clarifying what an alphanumeric letter is. So it's just A to Z or a number. So let's have a look at the first example. Was it a car or a cat I saw? So it's basically W-A-S, I'm just reading this front to back as usual, as normal I mean, S-A-W. If I do it backwards again from here, it is W-A-S-S-A-W. Well, look at that, it's the same. Very cool, and that's why it's true. And why is this false? Because it's T-A-B-A-C-A-T, and I read it backwards, it's T-A-C-A-B-A-T. There's a discrepancy here. All right, so let's just try solving this. Now, if you were to do the method that I just did, which is to kind of write everything out front to back and then write it again back to front, that's actually like pretty valid. Because if you think about it, it's like one pass reading the string from left to right and another pass from back to left, and that's O of 2n, which is linear time. That's not bad. Don't even need extra memory or anything. But I've got a better solution for you. You see, this valid palindrome is kind of like an introductory kind of easy problem to ease you into the technique that is called two pointers. So two pointers, as the name suggests, is a technique that involves two pointers. Wow, shocking, crazy. And this improves time efficiency. So let's see how this works in action in the valid palindromes question. So given a string race car, I'm gonna have a pointer on the first index and the pointer on the last index. So, you know, programmatically, what does that look like? So let's say I have L and R. This represents this represents this, okay? And now I'm going to initialize them to 0 and length of S minus 1. Well, effectively, right? So what can we do with this? What can we do with just two pointers? So if I were to say, if this and this is equal, and this is equal, and this is equal, and well, this and this points to the same character, they're on the same index, so obviously they're equal. So if all of that is true, then you can say this is a palindrome, right? And then in a more complicated string, for example, I'm gonna modify this a little bit. I'm gonna add a question mark here, and maybe make this like a capital R or something, right? So in the case of this, then, well, we have to modify our algorithm a little bit. If we encounter a non-alphanumeric character, in this case we encounter this question mark, then we kind of want to skip it, right? We want to skip it, and if this is also a question mark, then we skip this one too. But it's not, so we stop here. So for the special characters, it's pretty simple. We just skip them, and then once we arrive at two characters, we just compare them, right? We can ignore the case, and then we can say, hey, is this the same letter as this? If yes, then, well, then we have to compare the next one. But if no, if this is a B, then it's not a palindrome. Yeah, it's a pretty simple algorithm, honestly. We can try coding it. All right, now that we know what we want to do, the solution is actually pretty simple. It's pretty much just one-to-one with what we've talked about just now. So, to get the case insensitivity trait out of the way, we could assign S to this, right? This is just going to turn the entire string into lowercase, and then we're going to reassign that back to S. And then after that, we're going to write a while loop. Well, L is less than R. So what does this mean? So we know in our algorithm, let's say we have L here and R here. We're continuously going to check these characters over and over again. If we're able to successfully reach the middle before finding some kind of anomaly, then we can say that if they're both pointing at the same index, we can say that it's a valid palindrome, right? So in the case where a string doesn't have a middle, then, for example, something like this, once R starts becoming less than L, then this is also a position for us to be able to conclude that this string is a palindrome. So that's why we set up the condition this way, because we're gonna have a return true on the bottom here once all the checks here are done. So let's write the checks themselves. First thing we have to handle is the special characters, so non-alphanumeric characters. To handle those, we just do a simple if check. If we find a special character in the L index, then what we're going to do is that we're going to increment L to skip over that character, right? And then I'm going to add a continue here, because what if L happens to find 2 special characters? Then we want to skip over it once with the first loop, and then we go back to the top, and then we'll repeat the same check again. I just replaced the L's here, so it's a little bit more readable. So right side is pretty much the same logic. You're going to decrement it by 1 because we're moving it to the left side, and we're going to continue. So that's the logic for dealing with the special characters, and this one deals with the case insensitivity problem. Then finally, we've arrived at the actual comparison themselves. So at this point, the characters at pointers L and R have to be alphanumeric, and we know they're both lowercase. So we can compare them simply. If the character at L is not equal to the character at R, so that means we have a case of something like this. Let's say this is R and this is K. This is not a palindrome, obviously. We're going to return false, right? This is the failure case. But if it is the same, then we have to increment L and R as discussed. L plus 1, and then we'll give R a minus 1. And that's pretty much the code. For the time complexity of this, well, running this s.lower is O of n, because we have to reserve a block of memory and then transfer the characters one by one, but lowercase. So you know, that's going to scale with how large the input size is. And then for the rest of this, we're actually going to process each element exactly once. There's no overlap. And every operation that we have in here is an O of 1 operation. So the time complexity of this while loop is also O of n. So we can say the overall time complexity is O of n. As for space complexity, technically speaking, when we run this, it's going to create an intermediary block of memory, which is going to hold the lowercase characters. And then this block of memory is going to be reassigned to the S variable, which is our input variable. So whatever information that S was holding will disappear and be replaced with this new block. So technically, for a short while, you will have both blocks existing simultaneously before the assignment happens. But after the assignment happens, you know, we're not taking up any extra space. So we'll say space complexity is O of 1. And that's it. That's the valid palindromes problem. Okay, bye.